For my project, I researched the physics behind Teslas and the type of batteries they use in their electrically powered vehicles. I think this is a really important field because so many people globally are becoming more focused on decreasing individual carbon footprints and global greenhouse gas emissions. And there are a lot of measures being taken in this field to decrease these values. However, I see it really fall short when it comes to transportation, especially for people who live in more rural areas and don't have access to mass transportation, people who can't bike far distances to get to where they need to be, people who aren't capable of biking. So I see a really bright future in terms of electric vehicles in the future they have in our world. It was only in recent years that Tesla vehicles initially had come across my radar, but they have really captivated the attention of many people with their sleek yet really simple battery-powered vehicles. It's my hope from this project to learn about the type of battery used in Teslas, how they've engineered them to have ranges of more than 350 miles, as well as how long the batteries themselves are designed to last. The batteries used in Teslas and other car companies are rechargeable lithium-ion batteries. They're characterized by the movement of lithium ions from an anode through an electrolyte to a cathode, where they're neutralized during use and then move back towards the anode when charging. The most common combination of cathode-anode material in cars is lithium cobalt oxide as the cathode and graphite as the anode, with ether being an organic electrolyte that the ions move through between the two. Due to the smaller atomic size of lithium ions, they're capable of having a pretty significant ratio of voltage and stored charge per unit mass and volume, which makes them a really great asset for this field of electrochemistry. And when compared to two other commonly used rechargeable batteries, nickel cadmium and nickel metal hydride, lithium-ion batteries can deliver 3 times their voltage. There are, however, some drawbacks to using lithium-ion batteries, specifically within the realms of safety. For example, these batteries are susceptible to overheating and have even succumbed to combustion. In 2013, a Boeing 787 was forced to land mid-flight due to its battery catching fire, and there have also been many phones that have spontaneously ignited over the past few years as well. Another drawback of these batteries is their cost, which for Tesla is about 40% higher than the nickel-cadmium batteries, due to the additional cooling systems that are in place in Teslas that maintain a temperature of about 25 degrees Celsius within the battery and a maximum of 35 under extreme conditions. So even though they're more expensive, they definitely have safety measures in place that can help avoid combustion. When it comes to recharging these batteries, a quick turnaround is really wanted because it's less than desirable to stop for extended periods of time when driving long distances. So what Tesla has done is they've installed supercharger DC stations worldwide that supply 135 kilowatt hours of power to charge the battery pack, taking about 20 to 40 minutes total to charge the battery itself. So it definitely does take some planning to drive long distances with an EV, but ultimately the positives of not having to spend gas money and limiting your personal carbon emissions are unchallenged. In Teslas, their battery system, or energy storage system as they call it, consists of about 6,800 individual lithium-ion cells. It weighs 900 pounds and generates more than 100 kilowatt hours of power. So, using the same design, Tesla has outdone itself recently in the release of newer models by increasing battery range from 315 miles now up to 375 miles on one charge. The company has achieved these impressive stats through some pretty extensive efficiency refinement. For example, they've optimized the motor they use in the vehicles, they've improved regenerative braking, and they've also improved lubrication within the car itself to overall increase efficiency by more than 90%, leading to this extensive battery range. So lithium-ion batteries themselves have a self-discharge rate from about 1.5% to 2% per month. And self-discharge is just the chemical reactions that take place in the battery that decrease the charge it can hold. So a Tesla Model S, after being driven 31,000 miles, experienced just a 5% decrease in battery life. I'm from Vermont, so I did the calculations that since every Vermonter drives an average of 13,500 miles annually, in over 2 years of use, this battery would have experienced just about 0.2% degradation per month. And this trend line suggests that over a course of 155,000 miles driven, the battery still would not yet have experienced 10% degradation. So it's my hope that as the transition to greener and more electric solutions continues to grow globally, more people will recognize the need for change in terms of transportation and the significant role that it plays in global emissions. Whether it be a Tesla, Kia, Ford, or Nissan, the lithium-ion batteries are an extremely valuable asset by not only increasing the affordability of rechargeable cars, but just making them more accessible to everyone. Through this project, it's become increasingly clear to me that the need for electric vehicles really has the power to change the future of transportation and the future of our planet.